Welcome to this explainer. We're jumping right into one of the most nail-biting architectural rescue missions in history, saving the Leaning Tower of Pisa. You know the tower, you've seen the photos, but what we're looking at today is the sheer panic behind the scenes. We're talking about the incredible, almost unbelievable lengths modern engineers had to go to just to stop this iconic structure from totally collapsing into a pile of rubble.
So, let's set the scene. The year is 1990. The situation with the tower has escalated from a charming historical quirk to a full-blown, terrifying global emergency. Why the sudden panic? Well, just a year earlier, in 1989, a very similar historical tower in the nearby city of Pavia had suddenly collapsed out of nowhere. Boom, gone. Authorities were on incredibly high alert, and when they officially measured the Pisa Tower, it had reached a staggering tilt of 5.5 degrees. It was literally on the absolute brink of destruction.
To save the monument, the authorities had to make a really tough call. For the very first time in its long history, they completely closed it to the public. They went into full panic mode. They even hauled the massive, heavy bells right out of the upper bell chamber, just to shave off any extra top weight that might pull the structure down. Then they hastily put together a top-level engineering committee with one singular monumental task: prevent an imminent catastrophic collapse. And guys, this kicked off a desperate decade-long rescue operation. But, to truly understand the root cause of this modern crisis, we actually have to rewind the clock way back to the year 1173. The people of Pisa decided they wanted to build a campanile. That's basically just a traditional Italian freestanding bell tower, usually built right next to a church. Pisa already had this beautiful cathedral, and they simply wanted a magnificent, towering bell tower to stand proudly right beside it.
Here's where it all went wrong. The ancient engineers made a colossal blunder right out of the gate. They dug a foundation that was only 3 meters deep. Now look, 3 meters might be totally fine if you're building on solid rock, but they were building on terrain that used to be the ancient path of the Arno River. The ground underneath was literally just soft, marshy silt, sand, and clay. They essentially decided to build a massive, heavy stone skyscraper on top of a giant wet sponge.
And that brings us to one of the most massive historical ironies ever. Construction kicks off in 1173. By 1178, they hit the third floor and, surprise, surprise, it starts leaning. The heavy marble was just crushing that soft river silt on one side. But then, war breaks out with neighboring city-states and construction completely halts. They didn't touch it for 100 years. And believe it or not, breaking out into wars actually saved the tower. That massive 100-year delay gave the soft soil underneath the time it desperately needed to naturally settle and compact. If they had just kept building back in 1178, it would have toppled over right then and there.
Let's skip ahead to 1272. When new architects finally take over a century later, they realize the tower is already obviously tilted. So, did they tear it down? Nope. They tried this totally bizarre architectural hack. To correct the tilt visually, they just built the upper floors taller on the leaning south side. They used larger stones and even altered the stairs up to the bell chamber, putting 4 stairs on the south side and 6 on the north. This desperate attempt to force the tower straight literally turned the whole structure into a curved banana shape.
But here's the thing about gravity. It simply doesn't care about architectural optical illusions. The tower just kept sinking deeper and deeper into the soft earth. By the time the tilt was officially measured for the very first time in 1817 using proper instruments, it was leaning at a highly dangerous 4.5 degrees. And get this, its original foundation was already completely swallowed up beneath the ground.
So, with the tower continually sinking over the centuries, people naturally felt compelled to intervene and help it out. But as we're going to see, human intervention almost always made things drastically worse. For instance, do you think digging a beautiful, decorative walkway right around the base finally fixed it?
Yeah, definitely not. In 1834, an architect thought it would be a brilliant idea to dig a catino, basically a walkway around the base so tourists could walk down and admire the ancient buried foundation. But this excavation exposed the base, allowed water to seep right in, and completely disrupted the delicate soil balance. This single aesthetic choice caused the tower to sink even further, resulting in a sudden 0.25-degree jump in the tilt.
Okay, so if a delicate walkway didn't work, what about sheer brute force? Could a dictator's concrete injection straighten the tower out? Let's jump forward a century to 1934 and look at Italian dictator Benito Mussolini. He absolutely hated the crooked tower. He thought it was a national embarrassment, so he attempted to just force it straight. Mussolini's engineers drilled holes directly into the foundation on the high north side and pumped in 90 tons of heavy concrete. They thought this would somehow anchor it and pull it upright. Well, it backfired spectacularly. The immense concentrated weight of all that concrete simply crushed the soft soil underneath. Instead of lifting the south side up, it pushed the whole structure deeper into the mud, worsening the tilt and pushing it ever closer to that fatal 5-degree mark. So, jumping back to our 1990 crisis team, remember that terrifying 5.5-degree emergency we talked about earlier? Well, they knew they couldn't make the same heavy-handed mistakes. Their first emergency stopgap was visually jarring but totally necessary. They built a sturdy concrete ring around the base and just stacked 600 tons of solid lead counterweights right on the high north side, and miraculously, it worked as a temporary fix. It stopped the movement and reduced the tilt by a tiny 0.01 degrees.
But obviously those lead weights were just an ugly temporary bandage. In 1995, engineers came up with a permanent plan. They wanted to anchor steel cables to the solid bedrock 40 meters down. But they hit a huge problem. The water table there was extremely high. Digging would cause the mud to just wash out and accelerate the collapse. So they proposed a radical idea. What happens if you pump minus 200 degrees Celsius liquid nitrogen into the ground to freeze everything solid before you dig?
Well, physics took over. The 1995 liquid nitrogen experiment was an absolute nightmare of a backfire. When the liquid nitrogen froze the groundwater, the water expanded, as ice does. This expanding ice violently heaved the soil upward on the north side, which dramatically pushed the tower even further south. The entire structure groaned and shifted. It forced the panicked engineering team to quickly throw on 300 more tons of emergency lead weight just to stop it from falling over right then and there. Completely out of conventional options, the team turned to one final, nail-biting solution known as under-excavation. Now, this is a highly delicate process. It involves drilling diagonal holes to extract incredibly small amounts of soil from beneath the high side of a leaning structure, slowly coaxing it to settle back down into the empty space. These engineers were terrified of making a fatal mistake, and you can't blame them. So first, they cautiously tested the whole process on a 7-meter concrete model nearby, just to get the drill angles exactly right. Second, taking absolutely zero chances, they secured the real tower with massive steel cables. Third, they slowly drilled under the high north side and carefully extracted tiny bits of soil. Finally, as the empty holes collapsed, the tower naturally righted itself. In a tiny 1-meter test area, it successfully corrected the tilt by 0.1 degrees, a huge win. Emboldened by this initial success, the team decided to roll out the full operation. They deployed exactly 41 guide drills, side by side, to carefully, surgically remove soil across a wider 2-meter area beneath the foundation. Slowly, day by day, millimeter by millimeter, the massive stone tower began to gently rotate back toward the north. Now, with this incredible drill technology working so perfectly, it raises an obvious question. Why didn't they just stand it up perfectly straight? Well, the authorities stepped in with a serious reality check. They knew that if they removed the famous lean entirely, it would just become the Straight Tower of Pisa. The millions of tourists would simply stop coming, and it would absolutely ruin the local economy. So the goal was actually never to fix it completely, just to make it safe.
After a decade of painstaking, high-stress work, the tower finally reopened to tourists on December 15, 2001. But the engineers didn't just walk away. They left behind a brilliant permanent defense system. They dug 3 water wells on the north side. Now, the underground water levels are constantly balanced to prevent the soil from softening unevenly. Coupled with a permanent concrete ring securing the base, the groundwater is actively managed to stop any future sinking.
The miraculous result of this engineering triumph was a permanently stabilized angle of 3.97 degrees. They successfully rewound the clock. They took the tower back to the exact tilt it had roughly 2 centuries ago, effectively reversing hundreds of years of gravity's relentless pull. As we wrap up this explainer, it leaves us with an incredible thought to ponder. Human error created this iconic masterpiece, and unprecedented modern engineering genius ensured it remains suspended in time. But it makes you wonder, will this beautiful mistake ultimately outlast the very engineers who saved it? Thanks for joining me on this incredible journey through time and engineering, and I'll see you in the next one.